All right. Good morning, everyone. My name is Christopher Rosario from the Guam Department of Agricultural Biosecurity Division. And I want to also introduce Dr. Ross Miller, who will not be giving part of this talk today, but I would like to acknowledge that he has helped contribute to setting up a platform to my research that's been currently ongoing for about 8 years. And my talk will be based on the prevalence of honeybee parasites, predators, and diseases on Guam. So, what is colony collapse disorder? Colony collapse disorder is basically a phenomenon, or it's essentially where worker bees in an existing colony leave and do not come back, leaving a queen behind, leaving several pounds of honey and a few nurse bees. But colony collapse disorder was first reported in 2006 and was first observed by a Florida beekeeper named David Hackenberg. And this caused a lot of stir-ups in the apiculture industry, or in the pollination industry in general. In 2009, the USDA APHIS, in collaboration of University of Maryland, USDA ARS, which is Agricultural Research Service, and the state apiary specialists from across the nation funded what we call the National Honeybee Survey. And so in 2013, Guam became a part of the survey. And this is where my research has essentially started, and it actually excelled the apiculture industry for Guam. So a little bit of background or some history of how honeybees have came to Guam. But essentially, we're looking at how the map basically is showing the movement of Apis mellifera across the globe. And today we have about 22 subspecies of Apis mellifera. And if you see these gray boxes here, gray boxes actually show these subspecies. And some of these subspecies have a certain variety, or they give out a certain variety of traits, such as aggression, production of honey, production of larvae, color, size, etc. But if we start in Europe and then end up in the eastern US, so in the eastern US, Apis mellifera first came to the eastern US in 1622, and then on to the western US in 1853, and then moved to Hawaii in 1857, and then on to Guam in 1907. And so I project this is how Apis mellifera had moved to Guam from Europe. So in 1907, bees were introduced, and then into Guam, and then in 1911, USDA had closed importation of honeybees due to the potential of bringing in diseases. So basically, the survey consisted of me surveying for the different types of pests, parasites, and diseases. And so the great banded hornet was considered a pest or a predator up until it was introduced in 2016. And then small hive beetle, which currently isn't present. And then wax moth, which has been present for many years. And then if you look at the certain bacterial diseases that I also look for, which is American foul brood, European foul brood, some fungal diseases, chalk brood, and some protozoan diseases, which is Nosema cereniae. But the big one that I look for is this parasite called the varroa mite. And this varroa mite is actually responsible for transmitting many viral diseases. And one of them, which is the most popular one, which is deformed wing virus. And again, deformed wing virus You already know the name. It's basically causes the bees to have deformed wings when it's born. And so here's a list of viruses that I also sample for. I don't analyze the 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 samples for these viruses. So we send off our samples to University of Maryland. They do have the RNA kits and the lab certification to do this. Um, but again, in particular, I look for, again, the deformed wing virus, which is transmitted by the veromite. Bees can't fly. Bees that have the virus, bees can't fly, bees can't forage, and therefore they have no purpose. So, so part of my research is to, again, locate, examine, and sample. And as you can see that we take, basically take our examinations pretty serious. It takes about 4 people to even look at some of the brood diseases. And what exactly are we looking for? These examination of diseases, essentially we look for, again, American foul brood, European foul brood, sac brood, and chalk brood. And we look at the appearance of the combs, the age of the dead brood, color of dead brood. By the way, I'll back up for a little bit. What is brood? Why do I keep saying that? Brood is basically all the all life stages of the honeybee except the adult stage. In particular, we examine the larva and the pupa stage. And nonetheless, we also look for if eggs are present, because if we don't find eggs, then we don't have a queen. But for the most part, to examine certain diseases, we actually look at the larva and pupa stage. And so we look at certain symptoms, such as like the odor. The odor is really important here, because it could really tell you a lot what type of disease it is, or whether your colony is going through some type of disease. So what I essentially would do is have this apiary data sheet that I take out in the field with me and basically use it to record my findings. Notice how in the colony number section, it has about, it goes up to number 8. So at maximum, if I'm in an apiary consisting of 30 bee colonies, I'm required to sample only 8. But say for instance, if I'm in an apiary consisting of only 4 colonies, then I sample all of the colonies in that apiary. So just remember, an apiary is consisting of multiple bee colonies. Now in the mainland US, usually apiaries range from 100 to 1,000. Of course, we don't have that kind of, we don't have big scale or apiculture here on Guam. So usually beekeepers on Guam average for about 3 to 4 bee colonies. And in fact, in 2013, we only just had a handful of beekeepers that had about 10 colonies at the most. Today, now we have quite a few, and I'll explain that in a bit more. So for the sampling, I do 3 types of samplings. I basically collect bees and alcohol, which helps me find, again, all these samples are sent off to University of Maryland, but however, the alcohol samples I look in particular because I can find the veromite. So I can find the veromite before I can even send these samples off. But I sample bees and ethanol in an Nalgene bottle, 500 mLs. And then I also sample the combs, doing what we call a bump sample. So I take a frame of bees, or a frame of bees, shake the bees off, and that frame will consist of just the comb only, and I bump it. and basically bumping the frame to dislodge the mites and the potential small hive beetles into a bin with a small amount of ethanol. And then also I sampled the live bee samples. And when I talk about sampling live bees, I sample them into a box, and into a small box, throw that box into a freezer. The bees freeze, and then I pulverize them using a mortar and pestle, and I homogenize them in RNA later. And then those samples are then sent off. So we usually get back the results about 3 to 4 months later. And essentially the results, when it comes back, you have these check marks, which is colony field inspection, the lab diagnostics, and the molecular diagnostics, which basically includes everything I just talked about in the previous slides. So the results, so we're only gonna look at the results of one apiary sampled back in 2018. We don't have enough time to look at all the results, but essentially we have 9 colonies that have been sampled, and then 8 of them which has been sampled. And if you look at all of them, 0 out of 8, which basically did not have any types of the diseases, or from my field observation. And as well as, again, you get the pest results, the sample size of the bees, how many bees that were sampled. We do see that there are small amounts of nosema. And then results, third part of the results, which is essentially the viral analysis. And as you can see, we've been negative all across the board. And then apiaries in 2016, I wanted to basically show a map. The whole point of doing this map is to look at if urban or rural areas play a role in the prevalence of any diseases or pests. As you can see, we did have a presence of varroa mites in one of our apiaries. Again, I wanted to leave that disclosed, as you can see. But for the most part, we want to talk about discussion that colonies that were positive for varroa mites were immediately eradicated. And part of this eradication is because we didn't want the mites to spread. That was a huge turning point in my research, because we didn't know if the varroa mite did even exist in our colonies on Guam. And so now that we do know, then we took preventative measures to prevent the mite from spreading throughout the island. Nosema was present in 90% of our samples, and that's probably because nosema is highly prevalent in the tropics. No viruses were found in any of the apiaries, and it opens up a lot of research whether our queens are viral resistant, or if they're absent due to the isolation. The only predator we have currently is the greater banded hornet, which have caused several colony losses on island. And with these results, you have the growth of the apiculture industry. And that's essentially the end of my presentation. And if you have any questions, please let me know. Thank you.